All right, it's chip of the day. We have a Texas Instrument multi-point LVDS line driver and receiver, another serial differential pair type receiver type of thing. So there's lots of different versions. We've seen CAN, we've seen 485. This one is a SN65MLVD203. And it's going to look exactly the same as the other ones. It's got a transmit section, it's got a receive section, and this one is also, let's see, what voltages can this handle? Absolute max. Yeah, it's a 3.3. Also a 3.3. Everything's 3.3 these days. 3.3 volt part. Let's see here. What kind of milliamps are we looking at? Supply current, 16 milliamps. So, you know, it's driving a few milliamps down the line. This one shows it's going into a 50 ohm load. Yeah, here's differential 50 ohm. This one makes a lot of sense to me, though. Some of the other ones didn't make much sense to me. I always expected that when you take the differential, you'll end up with something that crosses zero. You'll get a plus voltage and a minus, and then you'll just compare it to zero, and you'll be all done. Now, a lot of these systems are boosted up so that they wiggle around a midpoint, so you don't have to have a negative voltage anywhere. So, but if you think about it differentially, it looks like it's crossing zero, but your zero is biased up. We'll see that on the scope here. It's going to look. It's just going to look like a driver. It's going to just push pull, wacka 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 type of thing. Here's a receiver. It just looks like a diff amp. Yeah, it's just real standard, goofy little stuff. It's just meant to be, you know, meant to always work. It's industrial grade, right? So let's hook one up, see how it works. All right, I've got my random generator and I've got the little part here. We'll take a look at it on the scope. All right, this is our input, 0 to 3 volts, wacka wacka wacka. And here are the outputs. They are 180 degrees out of phase, they're differential, but they wiggle around 1 volt. Okay, so it's a plus and minus with relations to 1 volt. So they've biased it up to 1 volt. So this makes a lot of sense to me. I mean, maybe you should bias it at 1.5, but this thing might go down to 2.7 volts, right? So they just put it at 1 volt, and that's probably 2 diode drops or something, you know, in the circuit. So it all makes sense. Let's see if we go to that one. Use my mouse. Keep your fingers off the screen. Once again, here's our input. And here are our 2 outputs. They're out of phase with one another. So a high or a low. Here, we'll stop it so you can look at it. So, you know, the green is high when the red is low, and vice versa, da-da-da-da-da. So, and it's wiggling around 1 volt. It all makes sense. And then if we take those 2 things and we subtract them from one another, you get this. This is just a mathematical subtraction. And they wiggle around 0. So yeah, so this one makes a whole lot more sense than a lot of the other ones in my mind. But yeah, the other ones work too. Applications, it's an alternative to the 485. Low power, high speed, short reach alternative. So maybe it doesn't go as far as the 485, but it's lower power and higher speed. Use it in back planes. And yeah, they always make this stuff up. They always make it up. It can drive loads down all the way down to 30 ohms. I'm driving it with 60 ohms right now. But yeah, you can have a 30 ohm resistor out there and it'll still drive it. And it will still wacka wacka. So there you go. Chip of the day was a 65MLVD203